Close your eyes. Take a slow breath in and let it go. Feel the weight of the day beginning to release from your shoulders, from your jaw, from the space behind your eyes. You don't need to hold any of it right now. Tonight, you are going somewhere far away. Tonight, we are going to Mars. Mars, the red planet, the fourth world from the sun. It has been watching us from the night sky for as long as human beings have looked up. A steady, rust-colored point of light that refused to behave like the other stars. While the stars held still, Mars wandered. The ancient Greeks called it a planetes, a wanderer, and they watched its wandering with a kind of awe that mixed fear with wonder, the way we feel about all things that move in ways we don't yet understand. Long before anyone knew what Mars was made of, before telescopes, before spacecraft, before the word planet had its current meaning, it carried a reputation. The Babylonians named it Nergal, after their god of plague and the underworld. The Romans named it for their god of war because its red color reminded them of blood. The Egyptians called it Herdesher, the Red One, and tracked its movements across the sky with careful, patient attention, recording the dates and positions in stone. But Mars is not a god, and it is not a battlefield. It is a world, a real, specific, remarkable world, with its own geology and its own weather, and its own ancient history, written in rock and ice and dust. A world that formed from the same spinning disk of gas and rock that made the Earth, roughly 4.5 billion years ago. The same neighborhood, the same beginning, but a very different life. Let your body settle a little more. Let your breath find its own slow rhythm. We are in no hurry. Mars has been waiting for us for 4.5 billion years. It can wait a little longer while you get comfortable. The journey we are taking tonight is not a fast one. It is not the kind that requires helmets or oxygen tanks or the roar of a rocket. It is the gentlest kind of journey, a slow drift through knowledge and wonder, through science and silence, through the story of a world that is, in so many ways, our nearest cousin in the solar system. Let the day go. Let the noise go. There is only this now, the quiet, and the story, and the red world waiting at the end of the dark. To understand Mars, we have to go back to the very beginning. Not the beginning of Mars specifically, but the beginning of everything in our solar system. A moment about 4.5 billion years ago, when a vast cloud of gas and dust, adrift in the galaxy, began to collapse under its own gravity. What caused it to collapse, we think, was the shock wave from a nearby supernova, a dying star that exploded and sent a ripple through the interstellar medium, disturbing the quiet cloud enough to set it moving. Once it began to collapse, gravity did the rest. The cloud spun as it fell inward, the way water spins as it drains. Conservation of angular momentum. The same physics that makes a spinning skater pull their arms in and go faster. At the center, the density grew and the temperature rose, until hydrogen began to fuse into helium and the sun ignited. Around it, the remaining material flattened into a disk, the protoplanetary disk, a rotating plane of gas and rock and ice slowly organizing itself into something. In that disk, tiny grains of rock collided and stuck together. They grew into pebbles. Pebbles collided and grew into boulders. Boulders grew into planetesimals, rocky bodies kilometers across. And the planetesimals, caught in each other's gravity, began the slow, violent process of accretion, sweeping up everything in their orbital paths, growing into protoplanets, and finally into the planets we know. Mars grew quickly, as planets go. Within the first 2 million years after the Sun ignited, Mars had reached most of its current size, pulled together from the material in its orbital zone, a region between the inner rocky planets and the vast, dominant gravity of Jupiter. And Jupiter mattered enormously to Mars. Because of Jupiter's great mass, the region beyond Mars, the asteroid belt, never managed to accrete into a planet. Jupiter's gravity kept the material there too stirred up, preventing the slow, patient collisions needed for a planet to form. This robbed Mars of material it might otherwise have swept up. Mars ended up smaller than it might have been, only about 10% of Earth's mass. And that smallness would define everything about its future. A smaller planet cools faster. Its interior solidifies sooner. Its magnetic field, generated by the churning of a liquid iron core, weakens and eventually disappears. And without a magnetic field, the atmosphere has no shield against the solar wind, the constant stream of charged particles flowing outward from the Sun. This is the story of Mars in a single, elegant tragedy. It was born just slightly too small, in just slightly the wrong neighborhood. And everything else followed from that. Let that idea rest for a moment. 4.5 billion years of consequence, all flowing from the simple fact of size. Sometimes the smallest things determine everything. Your body is growing heavier. Your breath is slower. The room around you is very quiet. If you could stand on Mars, if you could somehow be transported to its surface right now, the first thing that would strike you is the color. Not just red, but a whole range of ochre and rust and burnt sienna and faded amber. The colors of desert and iron oxide, of ancient rock ground down by billions of years of wind into dust so fine it floats into the atmosphere and tints the sky a pale butterscotch, a dusty salmon pink. The sky of Mars is not blue. It is the color of a sunset that never ends, a permanent, diffuse, warm haze that softens the edges of the horizon and makes the light feel heavy and ancient, as if the day is always late afternoon. The sun would appear smaller than it does from Earth, about 2/3 the size, but still blindingly bright in that thin atmosphere. There is no ozone layer on Mars to filter ultraviolet radiation, so the sunlight has a harshness to it, an edge, even though the planet receives less energy per square meter than Earth does. The landscape stretches out in all directions, with a stark, monumental emptiness. Not the emptiness of nothingness, the emptiness of immense space between features, of a scale that dwarfs anything on Earth. Craters everywhere, ancient, eroded, filled with dust. Some are small, a few meters across, fresh and sharp-edged. Others are so old and worn, they are barely dimples in the terrain, their original features smoothed by billions of years of wind and geological settling. To the north, if you were in the right location, you might look out across the vast lowland plain called Vastitas Borealis, the northern wilderness. This is one of the smoothest, flattest regions in the entire solar system. Scientists believe it may once have been the floor of an ocean. Billions of years ago, there may have been liquid water here, a shallow, cold sea in the northern hemisphere, fed by rivers that carved the channels you can still see in the ancient highland terrain. To the south, the terrain rises. The southern hemisphere of Mars is heavily cratered and sits, on average, several kilometers higher than the north, a difference in elevation that scientists call the Martian dichotomy, and which they still don't fully understand. Perhaps it was caused by an enormous impact early in the planet's history. Perhaps it reflects some ancient asymmetry in the way Mars cooled and solidified. The answer is still written in the rock, waiting to be read. And then there is Olympus Mons. Olympus Mons is the largest volcano in the solar system. It rises about 22 kilometers above the surrounding plain, nearly 3 times the height of Mount Everest above sea level. Its base is so wide, roughly the size of France, that if you stood at its summit, the edges of the mountain would be beyond the horizon. You would not be able to see them. You would stand at the top of the solar system's greatest mountain and feel as if you were on a gentle, slightly elevated plateau, with only the subtle curvature of the planet suggesting you were anywhere unusual. It last erupted perhaps 25 million years ago. By geological standards, that is recent. Mars is not entirely dead. And nearby, running across the equatorial region like a scar on the planet's face, is Valles Marineris, a canyon system that stretches nearly 4,000 kilometers from end to end. If it were on Earth, it would span the entire width of the United States. It reaches depths of up to 7 kilometers in places, dwarfing the Grand Canyon the way the Grand Canyon dwarfs a garden ditch. Valles Marineris is not, as it might seem, a river canyon. It was not carved by water. It is a tectonic feature, a vast system of rifts and chasms that formed as the crust of Mars was stretched and pulled apart, possibly as the volcanic region to its west, the Tharsis Plateau, pushed the crust upward and caused it to crack along the eastern edge. These are the landmarks of Mars, the Olympus and the Valles, and the great flat plains, and the ancient cratered highlands, all of them silent now, under that butterscotch sky. Once, a very long time ago, in the deep history of the planet, Mars was wet. This is one of the most extraordinary things we have discovered about Mars. And the evidence for it is written all across the surface, in a language of geology and chemistry that our spacecraft have been slowly learning to read. There were rivers on Mars, ancient, winding river channels cut into the rock, in patterns that can only have been made by flowing liquid water. There were lakes, dried lake beds identified by the flat, layered sediments that water leaves behind when it sits and settles over thousands of years. There were, perhaps, oceans. The evidence for an ancient ocean in the northern hemisphere is compelling, though still debated. The flatness of Vastus Borealis, the presence of what appear to be ancient shorelines, terraces in the landscape that suggest a water level held steady long enough to leave its mark. Minerals that form only in the presence of water, clay minerals, sulfates, carbonates, found in ancient rocks across the planet. The Curiosity rover, exploring Gale Crater, has spent years studying what was once a lake. The sediment layers in the crater tell a story of water that sat there for perhaps hundreds of thousands of years, long enough for complex chemistry to occur, long enough, theoretically, for life to begin its tentative first steps. How long ago was all this water? The oldest river channels and lake features date back to the Noachian period, named after Noachis Terra, a heavily cratered southern highland region. This period ended roughly 3.5 billion years ago, a billion years before the first complex life appeared on Earth. Mars was wet. And then, something changed. The climate shifted, the atmosphere thinned, the temperature dropped. The water froze, and then, over millions of years, the ice sublimated into the thin air, or retreated to the poles, or was trapped below the surface in permafrost that persists to this day. Why? The answer comes back to that same fundamental tragedy of size. As Mars cooled and its core solidified, the magnetic field that had protected its atmosphere weakened and died. Without that magnetic shield, the solar wind, those streams of charged particles from the sun, began to strip away the atmosphere, molecule by molecule, atom by atom, over hundreds of millions of years. Without a thick atmosphere, the atmospheric pressure dropped, and when atmospheric pressure drops below a certain point, liquid water cannot exist on the surface. It either evaporates directly into vapor or freezes into ice, with no liquid state in between. The water didn't disappear all at once. It was a long, slow loss. A planet growing colder and drier over hundreds of millions of years. Its rivers running thinner season by season. Its lakes retreating. Its seas evaporating. Until one day, and day here means a span of millions of years, there was none left on the surface at all. And yet, underground, there may still be water. The MARSIS radar instrument on the Mars Express spacecraft found evidence in 2018 of what appeared to be a subglacial lake beneath the southern polar ice cap. Liquid water, kept from freezing by the heat from the interior of the planet, sitting in the dark beneath miles of ice. Mars keeps its secrets well, but it keeps them underground now, in the cold and the dark, waiting. Let your breath be slow and quiet. The ancient ocean is very far away and very long ago, and the thought of it is as still as the planet itself. The question has been with us for as long as we have known Mars was a world. Could something live there? Has something lived there? Does something, somewhere, still? For most of human history, the question was pure speculation. Vivid, sometimes gorgeous speculation. But speculation nonetheless. When Giovanni Schiaparelli looked through his telescope in 1877 and described what he called canali on the surface of Mars, channels or canals, he lit a fire in the human imagination that burned for decades. Percival Lowell built an observatory in Flagstaff, Arizona, dedicated partly to observing Mars, and spent years carefully drawing the canals he believed he saw, weaving a story of a dying civilization that had engineered vast irrigation systems to carry water from the poles to the equator. The canals were not real. They were artifacts of the limits of early telescopes and the human brain's extraordinary talent for finding patterns, for connecting dots into lines, randomness into meaning. But the impulse behind Lowell's vision was real and understandable, and even scientifically reasonable. If Mars once had water, if it once had a thicker atmosphere, if it was once warmer, why not life? In 1976, 2 Viking landers touched down on the Martian surface. They carried biology experiments designed to detect signs of life. The results were ambiguous and have been debated by scientists ever since. One experiment, the labeled release experiment, produced a result that, if it had come from a sample of Earth soil, would have been interpreted as biological activity. But the other experiments found no organic molecules. The scientific consensus has generally been that the result was caused by chemical reactions rather than biology. But the debate has never been fully settled. The search has continued since then, grown more sophisticated, more carefully targeted. We now know that the key ingredients for life as we understand it, liquid water, organic chemistry, an energy source, were all present on early Mars. We know that microbial life on Earth can survive in conditions far more extreme than anything Mars has to offer. In acid, in radiation, in extreme cold, in rock, in the deep subsurface without sunlight. We know that meteorites from Mars have reached Earth, blasted free by ancient impacts, drifting through space for millions of years, falling through our atmosphere and landing in deserts and ice sheets. One of them, found in Antarctica in 1984 and designated ALH 84001, was found in 1996 to contain structures that some scientists argued might be fossilized microbial life. The claim was controversial then, and remains so, but it set off a new era of serious scientific attention to the possibility of Martian life. What do we actually believe today in the quiet consensus of the scientific community? We believe that if life ever existed on Mars, it was microbial, single-celled, simple, hardy. We believe that the most likely time for such life to have existed was the Noachian period, when water was liquid and conditions were warmer and the chemistry was right. We believe that if life exists there today, it almost certainly lives underground, protected from radiation, possibly near heat sources, possibly in the briny water that the radar data suggests may exist beneath the ice. We do not know. This is one of the most important things. We do not know. And not knowing, holding the question open, keeping the uncertainty, is itself a kind of wonder. To not know whether we are alone in even our own solar system. To not know whether the rust-colored planet hanging in our sky harbors, in its cold and ancient rock, the fossilized remnants of another beginning. The question breathes. It is alive in a way that answers are not. Let it settle into the quiet with you. The red planet, outside in the dark of space, keeping its secrets with the patience of 4 billion years. And you, here, warm and breathing, letting the mystery hold you gently as you rest. Mars has weather. Not the weather of Earth, not the roiling, moisture-laden, life-giving weather of our world, but weather nonetheless. Thin, cold, ancient weather that sculpts the landscape and fills the sky and occasionally transforms the entire planet. The dust storms of Mars are unlike anything on Earth. They begin small, a local disturbance in one region, a thermal differential causing wind, the wind lifting dust. On Earth, dust storms are constrained by terrain and moisture and the thickness of the atmosphere. On Mars, there is nothing to stop them. The dust rises into the thin atmosphere and spreads, catching more sunlight and heating the air further, driving more wind, lifting more dust. In the worst cases, the global dust storms that happened once every few Martian years, the dust spreads to cover the entire planet. The entire planet. A storm that blots out the sun from pole to pole, turning the world into a dim, rust-colored murk for weeks or months at a time. When NASA's Opportunity rover was caught in a global dust storm in 2018, the sky darkened so severely that the solar-powered rover could not generate enough electricity to function. It fell into a protective sleep, from which it never woke. The wind on Mars is persistent, but not powerful, because the atmosphere is so thin, less than 1% of Earth's atmospheric pressure at sea level. Even fast winds carry very little force. A wind blowing at 100 kilometers per hour on Mars would feel no stronger than a gentle breeze on Earth. It would not knock you down. But given enough time, even a gentle breeze can move mountains of dust, grain by grain, sculpting the landscape with a patience that dwarfs anything human. This is how the great dune fields of Mars were formed. Near the polar caps, vast seas of dark sand dunes stretch across the landscape, barkans and transverse dunes and star dunes. The same shapes you find in Earth's great deserts, formed by the same mathematics of wind and particle and gravity, just in slower motion over longer time. There are dust devils on Mars too, swirling columns of air that form when the sun heats the surface unevenly. They can be enormous, several kilometers tall and hundreds of meters wide, far larger than any dust devil on Earth. The Mars rovers have photographed them, these ghostly spinning towers, moving silently across the plain. The Perseverance rover, listening with its microphone, has actually recorded the sound of a dust devil passing overhead, a brief rushing of wind, the click of particles against the rover's chassis, and then silence again. That silence is the most Martian thing of all. Because whatever the wind does on Mars, however it sweeps the dust and spins its columns and reshapes the dunes, it does so in a silence that no human ear has ever heard in person. A silence of thin, cold air and vast, empty distances, and a sky that has not rung with any known living sound for perhaps 3 billion years. Let that silence come to you now. Let it fill the space around your body, easy and complete. The wind on Mars is moving dust across a plain, somewhere in the dark, and you are here, warm and still. And the silence is the same kind of silence, the comfortable, ancient kind. Mars has 2 moons. They're nothing like our moon, nothing like that familiar silver disk that hangs so large and luminous in our earthly sky. The moons of Mars are small and dark and oddly shaped, and they orbit their planet in a kind of quiet strangeness. The larger moon is Phobos, and it is remarkably close. It orbits Mars at an altitude of only about 6,000 kilometers, so close that it rises and sets twice in a single Martian day, moving west to east across the sky, in the direction opposite to the apparent motion of the sun. It is so close to Mars, in fact, that it orbits faster than Mars rotates, meaning that to someone standing on the Martian surface, Phobos rises in the west and sets in the east just a few hours later. Phobos is not round. It is lumpy and irregular, shaped a little like a potato. Its surface covered in deep grooves that may be the result of tidal stress from Mars's gravity. Every century, Phobos moves about 2 meters closer to Mars. In approximately 50 million years, it will either break apart, torn to pieces by tidal forces, or crash into the planet, leaving a ring of debris around Mars that will persist for millions of years before gradually raining down onto the surface. The smaller moon is Deimos. It is tinier, darker, farther away, and so small that from the surface of Mars, it would look like little more than a bright star, a point of light that moves slowly across the sky, easy to miss among the real stars if you didn't know to look for it. Both moons are thought to be captured asteroids, rocky bodies from the asteroid belt that strayed too close to Mars and were trapped in orbit by its gravity long ago. They are among the darkest objects in the solar system, their surfaces covered in a dusty, carbon-rich material that absorbs almost all the light that falls on it. Imagine lying on the surface of Mars at night and looking up. The sky is black, scattered with stars that don't twinkle because there is too little atmosphere to make them shimmer. Phobos races across the sky, small and fast, and faintly luminous. Deimos hangs nearly still, just another point of faint light. The sun has set, and the temperature is falling fast. Mars loses heat quickly without a thick atmosphere to trap it, and the night is very cold and very clear and very vast. There is something in this image, the cold plain, the black sky, the small rushing moon, that is both desolate and beautiful. Desolate and beautiful in the way that all wild, untouched places are, once you stop wishing they were something else and let them be exactly what they are. Let your eyes be still behind your closed lids. The sky above Mars is very dark and very clear. Rest in the dark. We have not gone to Mars ourselves. Not yet. But we have sent our machines, our careful, faithful proxies, to walk and roll and orbit and photograph and measure and taste the dust on our behalf. And they have been doing so for more than 50 years. The first successful mission to Mars was Mariner 4, which flew past the planet in July 1965 and sent back 21 grainy photographs, the first close-up images of another planet ever taken. They showed a cratered, barren, moon-like surface, and the scientific community was briefly deflated. This was not the Mars of canals and civilizations. This was a dead world, cold and scarred. But Mariner 4 only photographed a small slice of Mars, a particularly ancient, heavily cratered region. It missed Olympus Mons and Valles Marineris. It missed the river channels and the polar ice caps. It gave us a narrow window, and we mistook it for the whole picture. Science does this sometimes, not out of carelessness, but out of the irreducible limitation of working with incomplete data. Later missions revealed more. Mariner 9, arriving in 1971, was the first spacecraft to orbit another planet. It arrived during a global dust storm and had to wait weeks for the dust to settle before it could begin photographing. When the storm cleared, it discovered Olympus Mons and Valles Marineris. The world was astonished. The Viking landers of 1976 were engineering marvels, the first spacecraft to successfully land on Mars and operate on the surface. They photographed their landing sites in fine detail, measured the composition of the soil, listened for Marsquakes, searched for life. They operated for years beyond their design lifetimes, sending back data until they finally fell silent in 1982. Then came the rovers. Sojourner, the first, landed in 1997, a small microwave oven-sized vehicle that rolled cautiously around its landing site, bumping gently against rocks and analyzing their composition. It operated for 83 days. The mission team had hoped for 7. Spirit and Opportunity arrived in 2004, twin rovers whose primary mission was designed to last 90 days. Spirit operated for 6 years, becoming stuck in soft soil in 2009 and eventually falling silent in 2010. Opportunity operated for nearly 15 years, driving more than 45 kilometers across the Martian surface, climbing in and out of craters, photographing meteorites and mineral veins, and ancient sediment layers that told the story of water. Curiosity landed in 2012, and it is still operating today. It is the size of a small car, and it carries a laboratory's worth of instruments, cameras and spectrometers, and a drill for sampling rock, a weather station, a radiation detector. It has climbed the lower slopes of Mount Sharp inside Gale Crater, reading the layered history of the Martian climate in the rock strata, the way a geologist reads a cliff face on Earth. Perseverance arrived in 2021, carrying with it a small helicopter called Ingenuity, the first aircraft ever to fly on another world. Ingenuity was designed to make 5 flights. It made 72 before a rotor blade broke and it was retired. 72 flights on another planet, each one a small miracle of engineering and physics, in an atmosphere 100 times thinner than Earth's. These machines are not alive, and yet there is something that feels like tenderness in the way we follow their stories. The solar-powered Opportunity, sending its last message home as the dust storm darkened its sky, its battery finally draining. Mission controllers waited months for it to wake up, sending radio signals into the silence, hoping. It never answered. Its last transmission, reconstructed from the final data packet, was interpreted by one engineer as, "My battery is low, and it is getting dark." Perhaps the engineer was projecting human feeling. But the feeling is not wrong. The feeling of a small, faithful thing, far from home, doing its best until the last moment. That feeling is real, wherever it lives. Your breath is slow and deep. The rovers are still out there, some of them, rolling slowly across the ancient plain. Rest now. Let them keep their patient watch. A day on Mars is called a sol. It is almost exactly the same length as an Earth day, 24 hours and 37 minutes. Close enough that the first Mars rovers were operated on Mars time, with mission controllers shifting their schedules forward by 37 minutes each day, wearing special watches calibrated to the Martian soul, slowly drifting out of sync with the Earth-based rhythms of family and friends and daylight. Imagine the sun rising over Mars. It appears in the east, as it does on Earth, because Mars rotates in the same direction. But it is smaller and dimmer, and the sky around it is not blue, but a pale, dusty pink, the dust in the atmosphere scattering the light differently than Earth's air does. While on Earth, blue light scatters most in our atmosphere, giving us our blue sky, on Mars, it is red light that dominates, and near the Sun, the sky actually appears slightly blue. Sunrise on Mars, near the horizon, is blue. The rest of the sky is butterscotch. The morning is cold. The surface temperature at the equator might reach a comfortable 15 or 20 degrees Celsius on a summer afternoon, not unlike a mild day on Earth. But the nights drop to -70 or worse, and the mornings begin deep in that cold. As the sun climbs, the surface heats unevenly, generating the thermals and winds that sweep dust across the plains. By midday, the light is bright and harsh and slightly orange, and the shadows are sharp at the edges, despite the diffuse haze of dust. The landscape has a quality of stillness to it that is hard to describe. Not the stillness of a windless day on Earth, which still has the small motions of grass and insects and birds, but the stillness of a world where nothing rustles, nothing moves, nothing breathes. The afternoon shadows grow long, and the temperature begins its rapid fall. Mars has no ocean to store heat and release it slowly through the night. The heat it receives from the sun leaves almost immediately once the sun goes down, radiating back into space through the thin atmosphere. By evening, the cold is already serious, and by midnight, it is profound. The night sky of Mars is extraordinary. Without the light pollution of cities, without any cities at all, and with a very thin atmosphere, the stars are sharp and fierce and dense. The Milky Way arches overhead. Earth is visible, a blue-white star in the evening sky, sometimes bright enough to cast a faint shadow. If you were standing on the surface of Mars right now and looked up and found Earth, that small blue point, you would be looking at home across 80 or 100 or 300 million kilometers of vacuum, depending on where the planets are in their orbits. The light you were seeing left Earth minutes or hours ago, and somewhere on that pale blue star, people are going about their days, sleeping their sleeps, living their brief and miraculous lives. We are, from Mars, a point of light, a quiet, steady, unremarkable point of light. The thought is humbling and also somehow comforting. Everything you have ever known fits into a point of light. How small and how complete. Let your body be heavy. Let the night of Mars come over you, cold and vast and full of stars. You are warm. You are safe. The night is doing what nights do. At the top and bottom of Mars, where the planet's axis tips toward and then away from the sun, in the long Martian seasons, there are polar ice caps. They are not like Earth's polar ice. They are a mixture of two different kinds of ice, doing different things at different times of year. The residual polar caps, the ones that persist year-round, are made mostly of water ice. Ordinary frozen water compressed into layers hundreds of meters thick, built up over millions of years, like a geological record of the Martian climate. The layered deposits of the poles are read by scientists the way tree rings are read, each layer recording something about the conditions in that year. How much dust was in the atmosphere, how cold it was, how the axial tilt was affecting the distribution of sunlight. In winter, A seasonal cap of carbon dioxide ice forms on top of the water ice. Carbon dioxide, the main component of the Martian atmosphere, freezes out of the air at temperatures of about -125 degrees Celsius, falling as dry ice frost or snow onto the polar surface. This seasonal cap can extend to cover a quarter of the hemisphere in winter, and then sublimate back into gas in spring, causing the atmospheric pressure of the entire planet to fluctuate seasonally. The south polar cap is capped by a permanent layer of dry ice, carbon dioxide, that never quite fully sublimes. Beneath it, the water ice. Beneath the water ice, at depth, possibly the liquid brine that the radar instruments have detected. There is snow on Mars, not water snow, carbon dioxide snow, falling gently in the long polar night, settling onto the cap in layers so thin you could barely measure them. It is the quietest kind of snow, falling in a sky that makes no sound, onto a surface that has been quietly accumulating ice for longer than complex life has existed on Earth. The polar regions of Mars are, in their own way, among the most tranquil places in the solar system. Ancient, cold, slowly breathing in and out with the seasons, holding their water in patient storage against a future that may never come. There is something deeply restful about the image. Ice that has been ice for millions of years. Stillness that is geologically old. A kind of permanence that makes the concerns of a single day, a single life, feel small and light and easy to set down. Set them down. Let them rest in the cold with the Martian ice. From almost the moment we understood that Mars was a world, a real, specific, physical place, we began imagining going there. The first serious scientific proposals for a crewed Mars mission date to the 1940s and 1950s. Wernher von Braun, the German-American engineer who became the architect of NASA's Saturn V rocket, wrote a detailed technical manuscript in 1948 called Das Mars Project, the Mars Project, a meticulous engineering calculation for how a flotilla of 10 spacecraft carrying 70 people might make the journey to Mars and back. It was not science fiction. It was engineering, worked out in precise mathematics, by a man who genuinely expected it to happen within his lifetime. It didn't happen in his lifetime. The politics of the space race pushed attention to the moon, and after the moon landings, the political will for the far greater challenge of Mars evaporated. The cost was enormous. The journey would take 6 months each way. The astronauts would be exposed to cosmic radiation for over a year. The technology for landing heavy vehicles on the thin Martian atmosphere and launching them back to orbit did not yet exist. But the dream never went away. It moved through the culture like a persistent tide. Science fiction writers imagined Martian colonies in intricate detail. Scientists lobbied for the necessary technologies to be developed. Private companies were founded, with Mars as their explicit goal. And slowly, haltingly, the pieces have been coming together. We have developed better propulsion systems and better radiation shielding. We have landed increasingly heavy spacecraft on Mars, learning the aerocapture and retropropulsion techniques needed to slow down in that thin atmosphere. We have identified potential landing sites, mapped the subsurface for ice that could be used for water and rocket fuel, tested the production of oxygen from the Martian atmosphere. Perseverance has been storing samples of Martian rock in sealed tubes, leaving them in caches on the surface for a future sample return mission to collect and bring to Earth. The first Martian rocks to be held and studied in a terrestrial laboratory may arrive sometime in the 2030s. And the first humans on Mars? The honest answer is, we don't know when. The optimistic projections have been revised many times, but they have never been abandoned. The question has always been when, not whether. There is something deeply human about the persistence of this dream. We are a species that has always moved toward the horizon, that has always loaded what it could carry and set out across the water or the plain or the ice toward whatever was on the other side. Mars is just the newest horizon, the oldest impulse, dressed in new equipment. The dream is not separate from the sleeping. It is part of the same thing, the mind that reaches outward and then comes home to rest, and then reaches again. Reach gently now, and then rest. For the first time in the history of space exploration, we have heard another world. The Perseverance rover landed on Mars in February 2021, carrying 2 microphones, a first. Previous missions had included microphones, but they had failed, or the recordings were never transmitted. Perseverance succeeded, and in doing so, it gave us something no one had ever had before: the actual sound of Mars. The first thing scientists noticed when they listened to the recordings was the silence. Not complete silence, but a deep, underlaid quiet, unlike anything you hear on Earth. On Earth, even in the quietest places, a remote desert, a deep cave, a mountaintop in still air, there is biological sound. Wind through plants, the movement of insects, the distant call of a bird, the ever-present low-frequency hum of human activity. On Mars, there is none of this. What Perseverance recorded was the sound of a world that has no life making noise in it. Wind moving over rock, the creak and tick of the rover's own chassis as it heats and cools, the whir of the helicopter Ingenuity's rotors, and once, the faint crackle of a dust devil passing close by, a rush of air, particles against metal, and then silence again. The microphones also revealed something unexpected. Sound travels differently on Mars. Because the atmosphere is mostly carbon dioxide and is very thin, high-pitched sounds travel at a different speed than low-pitched sounds. On Mars, if you could hear someone speaking from 100 meters away, the high notes of their voice would arrive slightly before the low notes, creating a subtle but strange separation. Sound arrives at your ears in the wrong order. This is a world that would feel uncanny to our senses, even if everything else were familiar. And yet, the sound of the wind, just the wind, moving over rock in the cold, thin air, there is something elemental about it. Wind is wind. The physics is the same. Something about it feels both alien and ancient and entirely recognizable, the way a very old face sometimes does. The wind is moving over the rock right now, on the other side of the solar system, making its thin sound in the cold air. And here you are, listening to the inside of your own quiet, both sounds, both silences, both real. Mars has seasons. Real ones, like Earth's, because Mars, like Earth, has an axial tilt. Mars is tilted about 25 degrees from vertical, very close to Earth's tilt of 23.5 degrees. The same basic mechanism drives both. As each hemisphere tilts toward the sun, it receives more direct sunlight, and the temperature rises. As it tilts away, the light becomes more oblique, and the temperature falls. But the Martian year is almost twice as long as Earth's, 687 Earth days. So the seasons of Mars are long and slow. A Martian summer lasts for months. A Martian winter is a drawn-out, deep cold that settles over the land with a persistence that Earth's winters rarely match. There is another difference. Earth's orbit is nearly circular. Our distance from the sun varies only slightly through the year. Mars's orbit is more elliptical. Mars is significantly closer to the sun at some points in its orbit than at others. This means that the seasons in the two hemispheres are asymmetrical. The southern hemisphere has shorter, hotter summers and longer, colder winters, while the northern hemisphere has longer, milder summers and shorter winters. The southern summer is particularly intense when Mars is closest to the sun. It is the southern hemisphere's summer, and the increased solar heating is enough to trigger the large dust storms that can grow to cover the planet. The planet's own orbital geometry sets the conditions for its most dramatic weather. Over very long timescales, thousands to millions of years, Mars's axial tilt changes, oscillating between roughly 15 and 35 degrees in a complex dance driven by gravitational interactions with the other planets. When the tilt is high, the poles receive more sunlight, and the ice caps partially melt, releasing carbon dioxide and water vapor into the atmosphere, temporarily thickening it. When the tilt is low, the ice caps grow, the atmosphere thins, and the planet gets colder. Earth's axial tilt is stabilized by the Moon. Mars has no such stabilizer. Its tiny moons are too small to hold the tilt steady, and so Mars wobbles through its long cycles alone. Its climate seesawing over geological time, its ice caps advancing and retreating, its atmosphere breathing in and out, with a patience that makes human history look like a single afternoon. 4 billion years of breathing in and out. 4 billion years of seasons turning, ice forming and sublimating, dust rising and settling. The planet going about its ancient and unhurried business. And now it is night, and the season is whatever season it is, and the stars are out, and everything is moving very slowly, and there is nothing at all that requires your attention. Let the breathing of the planet find your own breath. Let the long, slow rhythm carry you. We study Mars, not only because it is fascinating, though it is, but because it is a mirror, a cracked, distorted, reddish mirror held up to our own world, showing us what Earth might have been and what Earth might become. The story of Mars is the story of what happens to a rocky planet when certain conditions don't hold. When the core cools too fast, when the magnetic field fails, when the atmosphere thins and the water retreats, when the climate tips past a threshold from which it cannot return. Earth is not Mars. Earth is larger, with a more active interior, a strong magnetic field, a dense atmosphere, and liquid water covering most of its surface. The processes that doomed Mars are not operating in the same way on Earth. We are not in imminent danger of becoming the red planet. But Mars teaches us that planetary climates can change fundamentally, irreversibly, over geological time, and that the conditions that make a world habitable are specific and fragile, and not guaranteed. This is a lesson worth learning and worth remembering. Mars also teaches us about ourselves, about the persistence of curiosity, about the willingness to invest enormous resources into the pure pursuit of knowledge, about a world we have never visited and may not visit in our lifetimes. There is something about the Martian missions that reveals something good about us. The careful, methodical building of knowledge, the setbacks met with problem-solving rather than abandonment, the community of scientists from dozens of countries collaborating across political tensions, sharing data openly, united by the simple, shared desire to understand. There is something in the act of knowing, really knowing, with data and measurement and repeated observation, that is itself a kind of affection. To study something carefully is to love it a little. To understand something is to feel, however briefly, less alone. We know Mars a little, and in knowing it, we are a little less alone in the solar system. Let that quiet feeling settle in you, the feeling of company across great distance, the feeling of the solar system as something like a neighborhood. After all, it is night on Mars. Not night everywhere. On the other side of the planet, the sun has risen, and the butterscotch light is spreading across the eastern horizon of Chryse Planitia, warming the ancient floodplain where Viking 1 once stood. But here, in the imaginary place where we have been watching, it is deep night. The temperature has fallen below -80. The frost, thin, ephemeral, almost invisible, has settled on the rocks. The small stars burn overhead without flickering. Phobos has risen in the west and set in the east already. And now it rises again, its lumpy shadow racing across the plain below it. The Curiosity rover is parked on the slope of Mount Sharp, its systems in low power mode, waiting for the sun. Its cameras are cold and dark. Its instruments are sleeping. It has been on Mars for more than 4,000 sols, and it has become, in its mechanical way, part of the landscape. Another rock on the hillside, slightly unusual in its geometry, quietly breathing the data that it was built to breathe. The Perseverance rover is parked not far from where it landed in Jezero crater, near a cache of sample tubes it has left on the surface, little time capsules of Martian rock, sealed and waiting for a future mission to collect them and carry them home. It is patient in its waiting, the way all machines are patient, not with the patience of restraint, but with the patience of not needing anything to be otherwise. The dust is settled tonight. The sky is clear. The stars are the same stars you can see from Earth, just rearranged slightly. The constellations shifted a little from the perspective of a different world. Orion is recognizable. The Milky Way arches across the sky. And somewhere in that sky, blue and steady, is Earth. Everything is at rest. The volcanoes that last erupted millions of years ago. The river channels that have been dry for billions of years. The ocean basins that have been desert for longer than complex life has existed. The ice at the poles, building its slow layers. The dust that was stone once and will be stone again. Everything resting, everything patient, everything ancient and quiet and continuing. And you, here, on the other side of the solar system, in the warmth and the dark, are resting too. Your body is doing its quiet work of repair. Your mind is softening at its edges, the borders between thought and dream, becoming gentle and permeable. The red planet goes on about its long, slow business. The solar wind streams past. The moons trace their orbits. The frost settles. The dust waits. You have learned something tonight about a world 4.5 billion years old, shaped by forces beyond imagination, keeping its secrets with the patience of deep time. About the machines we sent there, faithful and small, doing their best in the cold and the dark. About the water that was, and the life that might have been, and the question that still breathes. You have been, tonight, a little larger than your day, a little closer to the solar system you live in, a little more at home in the universe. Let that largeness rest with you. Let it be the last thought before the thinking softens completely. The stars are keeping their watch. Mars is keeping its secrets. And you are here, warm and breathing, on a small blue world that has been doing this, holding its living things through their nights for longer than you can imagine. Sleep now. Sleep well. The red planet will be there in the morning, hanging in the pre-dawn sky. Rust-colored, patient, and full of ancient wonder, waiting for you to look up. Sleep well. The red planet will still be there in the morning.